Hi, hello everyone. So this is the video dealing with section 4.3, right angle trigonometry, and this is the second part of the section dealing exclusively with these applications that we're going to see. Now, we're only going to see one type of an application. There's two types of problems involved, and it's dealing with what we call angle of elevation and angle of depression. So imagine that you have an observer at a particular location. And when we form a horizontal with the line of sight of the observer, then the angle of elevation is this angle going upward to the line of sight. And angle of depression is the angle going down, right? So here's the angle of elevation. And here is theta 1, the angle of depression to the line of sight. All right, so the angle of depression is going to be the angle below the side of the observer, and the angle of elevation, the angle above the observer. Okay, it's pretty much the same thing. And the most important thing here is, so take a look at the triangle formed on the angle of elevation. So here is a triangle, right? Here's my 90 degrees. Here's my hypotenuse. Here is my opposite side, and here's my adjacent side. And the same thing goes for the triangle on the angle of depression, right? So here is my hypotenuse. This is now my adjacent side, and this is my opposite side. So in either case, I can use the right angle trigonometry functions to find what it is that I'm interested in. So angle of elevation, angle of depression. Let's take a look at two or three problems. And in these three problems, we're going to see that we are either going to be required to find a value or to find an angle. So in example 6, we're going to have to find a value. Example 7, in this one, we're going to have to find an angle. Okay, so these are the two types of questions that you can have on this application dealing with either angle of elevation or depression. We either have to find a side or we have to find an angle. Okay, so let's take a look at the first example, 6. And as you can see, I am giving you a picture, right? And if these are questions on the exam, I'll also give you a picture to simplify the work. All right. Okay, let's take a look at example 6. So sighting the top of a building, a surveyor measured the angle of elevation. So we have to know what that is. So here's a surveyor, and here's my angle of elevation, 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Now ignore this 5 feet for now, okay? Because all we have to do is adjust later. So here's the 300 feet from the building. So this distance is 300. And we need to find the height of the building. So we need to know this h. Okay? Now, because this thing is 5 feet above the ground, we really cannot find h directly. It is easier just to find a. You see here, right? This is what we're going to find. This distance from the 5 feet height to the end. And then how do we find h? Well, we just add the 5. All right. So once we find the value of a, we just add 5. That's all. That's all we have to do. All right. Now let's transcribe this. And here's my triangle. All right. So just remove everything that we don't need. 300 and a. Now I have these three pieces of information. A that I need, I have 300 and I have the degree. Which of the three functions, sine, cosine, or tangent, allows me to find A? Well, now let's see. Sine is, what is the definition again? Opposite over hypotenuse. And I don't have the hypotenuse, so I can't use sine. How about cosine? Cosine is adjacent, which I do have over hypotenuse. I don't also Don't know if I can use that. Okay. I really don't. I'm sorry. Wait a minute. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And let's take a look at tangent. Tangent is opposite over adjacent. This involves something that I want, and I have the 300. And this doesn't work either because I don't have C. I could find C, but then I still have to find A, so that doesn't really help me. All right, so the function that helps me is tangent. So now we set it up, and I have the angle already. So tangent of 22 degrees equals opposite side over adjacent. All right, so I have this equation. How do I solve for A? Well, we just multiply both sides by 300. Okay, so now I have that A equals 300 times tangent of 22 degrees. Now, obviously, I don't know what tangent of 22 degrees, so I go to the calculator and I type all of this thing into the calculator. So here's my calculator. And I am going to do the tangent 22 first. So here is sine, cosine, and tangent. So tangent 22 degrees. Make sure that your calculator is in degrees, not in radian mode. Times 300. And I get about, I'm not interested in the decimal part, so I'm just going to say approximately 121. So A approximately 121. This is in feet, right? The original question was in feet. So 121 feet. So now go back to the picture because you don't have to worry about, the height, whatever above. We found A, okay? But so this thing is 5 feet above. So the height of the building H is whatever A is plus 5. So I am solving for H. I'm not solving for A. So H is 126 feet. Okay. So this is a simple application involving these trigonometric functions. In this case, we needed to use tangent. All right, let's take a look at the second problem, which is very, very similar. But now in this case, we need to find theta. All right, so example 7, a building is 21 meters tall. So now I am giving this distance, cast a shadow that is 25 meters long. Here is the shadow. Find the angle of elevation. So this is what I need to find. So here's my triangle. I need to find this. I have the 25 and I have the 21. So which of the three functions I need to use? So again, I have adjacent and I have opposite. So which is the function that does that? Right? It's obviously, again, tangent. So you set it up the problem this way. Tangent theta equals opposite over adjacent. So let's first divide 21 by 25. And we get 0.84. 0.84. So now I have tangent theta 0.84. Now, how do I solve this? Now, in order to find this angle that produces this value, we have to use the inverse function. So theta inverse equals, I'm sorry, not theta inverse. Theta equals tangent inverse of 0.84. So this is, it doesn't mean that tangent is raised to the power of -1. This just means that we're using the inverse function of theta to find the angle that produces the value of 0.84. Okay. So you go to the calculator for that. There's no way that we can do this in our heads. This is not one of the known angles. So we go to the calculator, and right above the sine, cosine, and tangent, you see in blue sine -1, inverse sine, inverse cosine, inverse tangent. So you're going to press second, in this case tangent, 0.84. And you are going to get this approximate value of 40. I'm going to ignore the 0.03. So approximately 40 degrees. Okay. Again, make sure that your calculator is in degrees, not radians. Okay, so theta is 40 degrees. So this is the other type of question that you may get. Instead of finding a value like example 6, you're going to find a angle. Now, what if the question had asked the following? Okay, so I'm going to write here, oops, I'm going to write here that this is approximately 40 degrees. What if they want us to find if somebody attaches a rope to the top of the building to the observer, how long would that rope be? Okay, how long would that rope be? We have two ways to do that. And I'm going to show you both ways because I want to prove to you the properties of the right angle functions work. Now, to find C, I can do it two ways. The first way that probably everybody would do it is use the Pythagorean theorem to find C. And we can do that real quick. So C squared is 21 squared plus 25 squared. Right, so we can do this very, very quickly. And then we would take the square root of both sides. And then we find the answer. Okay. Well, this is probably going to be an approximate value. So let's do that. So 21 squared plus 25 squared, and then we take the square root. All right, so let's see. So second for the square root, 21 squared plus 25 squared. All right, so we get 3264. So the length of the rope would be 32.64 feet. All right, this is from the Pythagorean theorem. Now let's use the trigonometric functions to see if we get one correct answer, a match, right? You should match. So I have all three values, but I am not going to use this. So I have the angle theta in here. This is the angle theta, which I already know it's 40 degrees. So I want to use a function in either 21 or 25 to find the length of C. Okay, how do I do that? Which function? So either sine or cosine will do. I'm going to use cosine. All right, so here's cosine of theta is the adjacent, which is 25 over C. Right, I want C, so this is perfect. And I have theta. We found out that theta is approximately 40 degrees. So this is going to be cosine 40 degrees equals 25 over C. And I'm solving for C. So what do? I multiply both sides by C. Right? They would cancel here. So now I have C times cosine 40 equals 25. And then I divide both sides by cosine 40 degrees. Which means that C is going to be 25 over cosine 40. And now let's go to the calculator and find out what that is because we need the calculator for that. So 25 divide, and by the way, so we're expecting the answer to be very, very close to 32.64. 25 divided by cosine of 40 degrees. So let's see what the answer is. 32.63. There you go. So this is exactly what we got. 32.63. So it's a match, right? It's very, very close. If we wanted to, we could make it uh, closer, but this is good enough, right? The exact same measure that we got. And you might think, well, Professor, how come the answer didn't match? Well, the answer didn't match because the angle was not really 40 degrees. Now, you remember it was 40.03, right? So this is going to be an approximation. But as you can see, it's extremely close to 1/100th of 1 foot. So it's very, very good. So this is the other type of question that you may be asked to find the angle theta. But as you can see, I can use for values, I can use either the Pythagorean theorem or the functions on the right triangle, and they both work. All right, so last question. I'm going to erase all of this. You can always stop the video if you want to. And the last application is dealing with the angle of depression. So a telephone pole is 60 feet tall. So here's the height of the pole. A wire is 75 feet long. So here's the wire, is my hypotenuse. And attached from the ground to the pole, top of the pole. Find the angle. Find the angle between the wire and the pole. Now, instead of saying find the angle between the wire and the pole, they could have said find the angle of depression. And you would know it's this angle and not this angle right here. So it's very important. Okay, so now I'm going to write the triangle the usual way so that we can just focus on the mathematics. Okay, so if I flip the triangle, this is my theta, this is my wire, 75, and the adjacent side is my 60 feet. Okay. And with this information, I obviously could use the Pythagorean theorem to find the side, but I don't really need it. I just need to know which function involves these two values. So if you don't remember, you can always try, right? Sine, cosine, and tangent. Sine is opposite over hypotenuse. Yeah, I don't have the opposite. But cosine is adjacent over hypotenuse. So this is exactly what I want. So I need to use cosine again. Cosine of theta equals adjacent side over hypotenuse. So I'm going to divide 60 by 75 on the calculator. So 60 divided by 75, we get 0.8. So this is 0.8. And now cosine theta is 0.8. And you already know how do I find theta? By using the inverse function. So theta is cosine inverse of 0.8. So this means find me the angle whose value of the cosine is 0.8. So we need the inverse property of the calculator. So again, we press second for the cosine inverse, which is the blue functions above the sine, cosine, and tangent. We type in the 0.8. And then we get the approximate angle of 36.86. 36.86 or approximately 37 degrees. So this angle right here is approximately, would say 37 degrees. Okay, so two types of applications using the angle of elevation and or depression. And sometimes we may need to find a value. And in this case, we needed to find the angle using the inverse property.